Okay, sorry about that. So let's look at this problem using today's method. It's called dimensional analysis. So this is how we would work this problem using dimensional analysis. You take your starting amount. So 9 yards. Okay, I write 9 yards down, 9 yards. If the starting amount is just a lump sum there, 9 yards, you need to have a fraction for this method. So this method uses fractions. I know that's the F word in math, y'all. But the fractions are just a way to organize. Don't think of fractions as like, calculations. It's a way to organize your work. So since I'm just given 9 yards, I need to make that into a fraction. So we can make any whole number into a fraction if you put it over a 1. And all that fraction is doing is separating information on the top and information on the bottom. Okay? Now, what this method does is it uses an idea from algebra that says this. Okay, if I took the number 9 and I multiplied by the number 1, everyone can do this, right? What's 9 times 1? It's just 9. It doesn't change. So instead of using a number 1 like we're used to seeing, we can make that 1 any special form of 1 we want. I could do 3 over 3. Is 3 over 3 1? Yep. So 9 times 3 over 3 is still going to be 9 because 3 over 3 is just 1. So we're not changing the amount. We're not changing the amount. We're just going to change the way it looks, because I could also do this. I can make the 9 over a 1. This is using some algebra here, some rules about fractions. If I multiplied straight across, that would give me 27 over 3. But isn't that just 9? 27 divided by 3? So we're using this idea that multiplying by 1 doesn't change the number. So I can multiply it by special forms of 1 and it won't change the amount. It might change how it looks, but it's not going to change the amount. So how does that even help me? This is how it helps me. I'm going to use a fraction as a conversion factor. Factors are things being multiplied. We're just going to create a fraction using this information up here. We're going to pick out information to make a fraction that's going to help us convert. So what's anything we know about yards? Let's look at our table. There's yards and meters over here, but that's not very helpful. Boom, right here. See how 1 yard cashes in for 3 feet? 1 yard cashes in for 3 feet. So what I can do there is I can say this. If 1 yard cashes in for 3 feet, then if I put 1 yard on top and 3 feet on bottom, that's just one hole. If I have 1 yard on top and 3 feet on bottom and they're the same thing, it's the whole thing, right? 3 feet is the whole yard. The whole yard is 3 feet. So see how that's just a special form of 1? And same if I put the 3 feet on the top and the yards on the bottom, and the 1 yard on the bottom, it still just cashes in for 1. 3 feet cash in for 1 yard. So we're going to use this idea that we can multiply by 1. It's totally allowed. But we're going to change the way 1 looks. I'm going to put the 1 yard in the denominator and the 3 feet in the numerator. It's just multiplying by 1. Who wants to either in the chat or unmute themselves say, why did I decide to put the yards in the denominator? Any idea? Why would I put yards in the denominator? If I can go either way, if I could put yards on top or yards on bottom, why put yards on bottom?
To have the same denominator?
Okay, well, almost, it has to do with something about the same. What's the same here?
I see, because you put I'm sorry, I didn't mean to yell.
That's okay.
The 9 yards as a numerator on the other side, and then the 1 yard as a denominator on the 3 feet, one thing, so they could cancel out.
Exactly. Now the yards in the numerator, we have that rule from algebra that says numerators can cancel out denominators. So if there's yards in the top and yards in the bottom, see how they cancel out? And now my answer's in feet. So if I stop right now, my answer is going to be in feet. But do we want feet? What is it asking us for? What do we want?
We want inches of ribbon.
Yeah, we want inches. So all we're going to do in this method is create another fraction. So I'm going to go look at inches. So 1 foot cashes in for 12 inches, right? So I can write that fraction two ways. I can say 1 foot on top and 12 inches on bottom, because 12 inches is the whole foot. Or I can put 12 inches on top and 1 foot on the bottom. So which one do I want to use?
You want to use the 1 foot on top and 12 inches on the bottom because there's the 3 feet. Oh.
Now careful, if I put the 1 foot on top and the 12 inches on the bottom, are the feet going to cancel the feet?
No, I'm sorry. No, it has to be the other way around.
There you go. That's okay. And hey, your brain is hardwired to learn from mistakes. So if I switch that around, now we can see that the feet on top are going to cancel the feet on the bottom. And my answer is in inches, which is what we want. So we've set up some calculations. All these fractions are doing is setting up calculations for us. And now you just use your calculator, okay? So now we're just going to get the same answer. What was it, 300 something? So let's go ahead and get that answer using our calculator. Yeah. I need to clear my screen though, because I just realized I'm not in my app. So let me rewrite this real quick. So 1 yard, I put the 3 feet 1 yard here. I put the 1 foot on the bottom. So 12 inches on the top. And then, okay. So if I go, my rule for algebra, so you do have to know the rule for fractions. You just multiply top times top. And that gives you was it 324? And then there's inches. And then if I multiply bottom times bottom, it's just 1. Yeah, so see how that works? That's just a different way to get the exact same answer y'all got using whatever method you wanted. So Corey said you did it differently, but did you still get 324, Corey, when you did it? Yeah, so it's okay to do it differently, but this method I'm showing you with the fractions, it looks scary at first. It looks scary because we hate fractions, right? Fractions. So don't think of these as fractions. Think of it as a way to organize units, because you could do number 1 your own way, right? But when you try to get the harder problem on the last slide, you're like, my way's not working anymore. This method that I'm showing you is going to work for every single problem, even the really, really hard ones, okay? So do y'all want to go over to the really, really hard one and do it this way and see the answer? Yeah, let's skip ahead. It's okay. It's going to be in the notes later, but it might be worth it to skip ahead. Lauren said she did 12 times 3 equals 36. Yes, that'll work too. So Rachel, the way you did it totally works. 9 times 3. Hold on real quick. I say it totally works. 9 times, 9 times 3 times, yes. Yeah, that works. Okay. And I know I just erased everything because I forget when I change slides on here, it erases everything. But that's essentially what I did, right? So I had 9 yards, 1 yard cashed in for 3 feet, 1 foot cashed in for 12 inches. My units canceled out. So see how I ended up doing 9 times 3 is 27? And 27 times 12. I did your same calculations. The fractions just ordered it for me. So it's just a way to organize your work. It's not like the fractions are really doing a part whole relationship job. They aren't. They're just organizing stuff. And you'll see this if you take chemistry at ACC. It's called stoichiometry. I don't know if that sounds familiar, but they use this process in chemistry too. So if you have to take chemistry, you're going to see it. So let's jump over to the harder one. Well, I don't know. We might as well do 2 here. You want to do 2 together? Let's go. Let's see if you get your exact same answer that you did in your group. But now we're going to use our method, okay? Let's do it. So it says, if a car travels at 60 miles per hour. 60 miles per hour. So you're going to have to do some interpreting here with the word per. See how there's a word per in there? So when I go to write my starting amount, it's 60 miles cashes in for 1 hour. Every hour I go 60 miles. Every 60 miles took an hour. So see how that information is related? But the way you're going to write it in your fraction, you follow the order of the words in the sentence. If miles comes first, that goes on top. Per means you're going to divide by. And then hour came second, so hour went on the bottom. So you set your fraction up for your starting amount. Miles per hour. Every hour cashes in for 60 miles. Every 60 miles cashes in for an hour. And then you say, okay, I want to go, my goal over here, what's my goal? My goal is kilometers per hour. Okay. Well, what sounds the same between my starting amount and my goal? What word is the same there for both of them? 60 miles per hour, kilometers per hour. So they both have a per, right? So see how they both have a per? What else do they have in common? Hour. So do I need to change the hours at all? No, right? We want to keep the hours.
No.
Yeah, keep the hours, right? Keep the hours. So here we go. So I just need to make a fraction that's going to change miles to kilometers. So let me find on my table that right here, miles to kilometers, right there. Miles to kilometers. So 1 mile cashes in, 1 mile cashes in for 1.609 kilometers, or I could write it the other way. 1.609 kilometers is going to cash in for 1 mile. You just have to decide which one of those you need given your starting amount, okay? So remember, I'm wanting to get rid of miles. Miles are on top, so I need to pick the fraction that would have miles on the bottom. That's correct, Tony. So the 1.609 kilometers is going to go on the top, and the 1 mile will go on the bottom. So now the miles in the numerator on my starting amount will cancel the miles on my, we call that a conversion factor. It's a fraction that's converting stuff for us. And then if I stop here, I'll see, okay, I'm going to have kilometers on the top, hours on the bottom. That's kilometers per hour. Kilometers per hour. So I know my units are right. I wanted kilometers per hour. I have kilometers on the top, hours on bottom. So now you're ready to calculate. And you just calculate by going straight across. I'm going to do numerator times numerator, denominator times denominator. So let's go ahead and do that. So that's going to give me, I have to type that in my calculator. I need to do 60 times this number. Give me 1 second. 60 times, there you go. So 96.54, and there's a kilometer on the top. And then on the bottom, it's just 1 times 1. 1 times 1 is just 1, and there's an hour on the bottom. Yeah, there you go. Good. So Jesus confirmed it. So see how this is just kilometers per hour? This many kilometers cashes in for 1 hour. 1 hour cashes in for that many kilometers. So the way we write this is technically you're dividing these two numbers, but dividing by 1 doesn't do anything. So we would say 96.54 kilometers per hour. I don't know. So you got that answer. A lot of y'all got this one right. You probably did it a totally different way, right? Like, oh, did I? Oops. That must have been a typo. But hopefully my math lab is programmed to accept a wide range of answers, because anytime we take a standard conversion to a metric, it's always, see how in the table here, it's all these approximate symbols. It's because you have to round to even go back. Like there's no exact amount for a kilometer and a mile, like you have to round. So my math lab should be programmed to accept a little bit of rounding error. If you get a question wrong on my math lab because it was a silly rounding error, please click ask the instructor and send it to me so you don't have to redo the whole question. I'll just override the grade. Sorry about that, guys. Okay. So how are you feeling so far? You feeling okay? Is anyone just totally overwhelmed? I don't know. Send me a status. How are you feeling about this process of writing your starting amount as a fraction, picking information out of the chart and making it a fraction, and then using those to get a calculation here? Like, not so sure. You're like, okay. Some people like it. Some people aren't so sure. So today's notes, yeah, today's notes are all about this, okay? It's all about what we're doing here. So here's my question. Do you want to just go to the notes where we maybe work some simpler problems? Maybe we should do, let's go to the notes and work some simpler problems. I just made a decision. And then we're going to come back. In the notes, I think it's like on the 3rd page or something, the notes have this really, really hard problem. So we're going to do this in the notes. Go ahead, Rita.
That's what I was asking because I couldn't get that one.
Yeah. This one's in the notes, but it's pretty challenging. Our method is going to work, but maybe we should, since some people are still uncertain on the method, let's go to the notes and do some simpler problems and work our way up to this one, okay? So let's go ahead and do that. Cool. So let me pull the notes up right now. So I'm going to navigate away from this PowerPoint and go back to my notes. So these are the notes that were posted on Blackboard like 5 seconds before class because I forgot to upload the calendar. So give me 1 second. Oh, my app is not showing up. Oh, there it goes. Okay. Here we go. So give it a second. That is not what I wanted. Stop that. Why is my app? There it goes. Okay, cool. Now it's working. Okay, so this is just the reference sheet that, you know, you'll get to use on a quiz. At the bottom though, before I forget, I wanted to emphasize on my math lab, do not use these numbers. This is what I'm going to give you. This is what you're going to use for a quiz. This is what you're going to use for the test. But on my math lab, they're going to see this little icon, and it's when you click it, it pops up a table. Make sure to use those numbers so your rounding matches how my math lab wants you to round. So basically, you can use, how do I want to say that? Give me 1 second. These numbers are safe to use because they're standard conversions, but the metric stuff might be rounded differently on my math lab. So always use what my math lab gives you, especially if it's metric. The other ones are standard. So I just wanted to point that out before I forget again. Cool. Okay. So let's pull up the notes and we're gonna do some more group work at the end if we have time. Let's go ahead and get our notes pulled up here. Okay. Oops. Starting again from scratch. So it's like you got a preview of this idea and now we're going to start again here. So this is, there we go. Okay. So I'm starting my camera. So starting fresh, we've already kind of talked about this. Normally we teach these sections over like 2 different days. So we already talked about units at the beginning of class. So this is just a review. What are units? Units are what you're measuring, right? It describes what you're measuring or it describes what you're counting. If you're counting people, your units are people. If you're counting inches, your units are inches. If you're measuring weight, your units might be like pounds or grams, right? So it's just when you measure or count something, you put a unit on it, on that amount to show what you measured or to show what you counted. Okay, so on word problems, you always have to put a unit on your answer to show what you were calculating. So for example, if you were calculating the distance from Austin to San Antonio, what units might go in your answer? What are some possible units you could use if you're measuring the distance from Austin to San Antonio? Drop it in the chat. What units might we put in there? Yeah, miles. Or if it was metric, what might I put in there? Yeah, if we were in a different country, if we're maybe in Mexico, kilometers. Yeah. So here we would probably do miles because that's what we're used to, or we could do kilometers. But if I didn't see miles, if you just put like 150 as your answer, I'd be like, 150 what? $150? 150 people? I'm going to play devil's advocate. You'd have to put 100. That's the distance from Austin to San Antonio. I don't have no idea, but are 150 kilometers. Like you have to put a unit to describe what you measured. And then if you were going to measure a speed, yeah, if you're driving, you're probably going to say like miles per hour, right? So you might say something like miles per hour. So sometimes, and we've already talked about this because we kind of let y'all try these on your own, you're going to see this word per in the unit. If you see the word per, that means you have a fractional amount. So the word per means you're going to have a fraction involved. So anytime you see the word per, you're going to have a fraction, which is what we want for this method. So when you see per, you should be excited. You're like, woohoo, I got my fraction. So let's practice that per a little bit. If on number 3, it says, suppose you're buying fruit at a price of $3 per pound. $3 per pound. I would write it like this: $3 on top per 1 pound on bottom. It's assumed to be 1 pound per pound, 1 pound. So you could write it as $3 per pound is $3 for 1 pound, you're assuming. If it's per gallon, it's 1 gallon. Per mile, 1 mile. Okay, what about this next one here? Oh, yeah, and then you might see, we did this in 0222, but there's some new students in this class. If you see the word square units, that means an exponent of 2. So square feet would be feet with an exponent 2 on it. So when you square, it's an exponent 2. If you see the word cubic, so 5,000 cubic feet, what exponent is that? Anyone know? Drop it in the chat. Cubic, what exponent is cubic? Square is 2. Yeah, cubic is 3 because a cube is 3-dimensional and a square is 2-dimensional. And we're going to talk more about this next class, but basically a square has a length and a width. That's 2 dimensions for a square, but a cube, oh my gosh. Okay, here's a cube. A cube has a length, a width, and a height. It's 3 dimensions. So cubic is 3 dimensions. So you would write 5,000 cubic feet, put a little 3 there, per, what was it, per second? Like that. So just keep those vocab words in mind. Okay, now we're finally getting into the process that we already kind of talked about here. So in this process, this unit conversion process, you have to have fractions, right? So we're going to practice taking information off a chart and writing a fraction. And we already did this in our warm-up, but if I have on my table that 1 inch cashes in, that 12 inches cashes in for a foot, if I give you 12 inches, you give me a foot. If I give you a foot, you give me 12 inches. If they cash in, you can write 2 different fractions. You can put the 12 inches on the top and the 1 foot on the bottom, or you can put the 1 foot on the top, the 12 inches on the bottom. You won't know which one you need until you look at your starting amount so you can see units cancel out, okay? So, question number 6 is asking you to write a relationship between seconds and minutes. So time, normally, like, I put some time information in the table, but a lot of the time information, they just expect you to know. So what do you know about seconds and minutes? 1 minute equals how many seconds? 60, right? 60 seconds. So this is the information you might see on a chart or a table, or if you Googled it, how many seconds in a minute? You'd Google it, it'd say 60 seconds in a minute, it'd look like that. But I can change that and I can put 1 minute on the top, 60 seconds on the bottom. Or I can put the 60 seconds on the top, the 1 minute on the bottom. I don't know which one I need yet, but I could go either way. So just practice, make sure you're reading off a table, and then you can put the fraction either direction. So let's see this in action on a problem here. And I have a whole bunch of notes here to help you. This will not be given on a test. On the test, this is what you're going to see. On the test, it's going to say, convert 20 feet per minute to feet per second, round to the nearest tenth. That's it. That's what you're going to see on my math lab. That's what you're going to see on a quiz. That's what you're going to see on the test. All this extra stuff is to help you train your brain as you're learning, okay? So this is what you're training your brain to do. You're going to say, okay, what is my starting amount? What amount were we given? We were given 20 feet per minute. That's your starting amount. So your brain says, okay, I have 20 feet per minute. That's what I'm starting with. Then you need to train your brain to say, okay, what was my goal? Like, what am I even trying to do? I'm trying to get, what, feet per second. I want to take feet per minute and make it feet per second. So my goal is going to be feet per second. Okay. Then you're going to train your brain to take that starting amount and you have to write it as a fraction. And I see that word per in there. So I'm going to do 20 feet on top per minute on bottom. 20 feet on top per minute on bottom. And that per minute is assumed to be 1 minute. Then you just have to figure out, how am I going to reach my goal? Which fraction do I need to multiply to reach my goal? So I come back up here and look at my work. They both have the word per, so that's in there. They both have the word feet. So do I want to change the feet? No, we want to keep it. So we're going to keep the feet. Let me write that down there. We want to keep this. Keep feet. So we want to convert the minutes to seconds. And I know this one was easy enough. You could do it other ways, right? You could probably do number sense or proportions or lots of different ways. I'm just showing you using this analysis method so we can work our way up to the harder problems. So here we go. So let's write it. So I need to choose between this fraction up here, about minutes and seconds, or this second fraction. If I want to cancel out minutes in the bottom, I need to pick a fraction that has minutes in the top. So I'm going to pick this fraction right here. It has minutes in the top. 1 minute is going to cash in for 60 seconds. So let's look at this checklist over here before we go on. So the checklist says, did you start with a given value as a fraction? Yes, we did. Did your units cancel? Ooh, do they? I don't know. Let's look. Did my units cancel? I have minutes on the bottom. They canceled minutes on the top. Yep, they did. Then I'm asking myself, did I end up with the correct units at the end? I ended up with feet per second. Was that my goal? Feet per second. Yep, that was my goal. Okay, so now let's do our calculation. Let's go straight across. I'm going to do 20 times 1, and then I have feet left. And then on the bottom, I'm going to do 1 times 60, and I have seconds left down there. Okay, so let's clean that up. That's going to be, so just multiply that, right? So 20 times 1 is just 20. So I have 20 feet on the top. 1 times 60 is just 60. I have 60 seconds on the bottom. But they want feet per second, per 1 second. So what you're going to do is divide top divided by bottom. Do top number divided by bottom number on your calculator to get the feet per second. So that's going to be 0.3 repeating feet per second. Yeah, is that what y'all got in there? Let's see. Yeah. Oh, not 3 feet per second. It should be 0.3 because you have to do top number divided by bottom number. Top number divided by bottom number. Yeah, I flip-flopped. I know our brain wants to do 60 divided by 20. Top number divided by bottom number. Cool, cool, cool. And it's weird. That's a weird number. We don't like it. Our brain's like, I don't like it. But basically, it's 1/3 of a foot. So less than 1 foot per second. About 1/3 of a foot per second is what we're doing there. And it's going to be the same process over and over and over and over and over again in these notes. Okay, so let's try another one. If you're still a little confused, that's okay. We're going to do the same process over and over again. Okay, you've already done this one, so we're not going to go through it together because look, this one is saying, let's just read it. You did this in your, oops, something weird just happened. Okay, sorry. We did this in our warm-up. So let's read. It says, you plan to go to France. So not now because there's a pandemic, but you plan to go to France. You know that the speedometer will be in kilometers per hour. Yeah, kilometers per hour. You want to know. Oh, sorry, Rihanna, you had I saw question marks there. Did something happen? Or was it a question? Oh, wait, or maybe. Okay, sorry about that. Okay, so let's look. So just to recap, we've already done this problem because this is saying you go to France, you know the speedometer will be in kilometers per hour. You want to know what 60 miles per hour is in kilometers per hour. We did this one at the beginning of class, so I'll write it up in the notes. But we did this one. Just to quickly go through it, what did we do? We're given 60 miles per hour. So remember we wrote that as 60 miles on top per 1 hour on bottom. We're given 60 miles per hour. We wanted some number of kilometers per hour. We see that the hour is the same. We want to keep that. We want to keep the hours. So I want to keep this. But then we picked some information off our table that would convert the miles part to kilometers. So we picked this mile kilometer information off the table. And that's what I'm going to put here to do my conversion. The way it stands, my miles are on the top. So I just want to put miles in the denominator of my table. So I want to make sure I have miles on the bottom, kilometers on the top. Okay, we can do that. So I just take this information up here, 1 mile, so 1 mile on the bottom, cashes in for 1.609 kilometers. So this is the same problem we did at the beginning of class. We'll see that our miles are going to cancel out. We're going to be left with kilometers per hour, which is what we wanted. And remember, we went straight across, and that's when I made that little typo with the decimal. It was 69.54 kilometers. Oops. Kilometers per hour. Kilometers per hour. I know I did that one really fast, but it's because we did it before the notes when I had y'all try it on your own. So any questions or comments about this one, about the process? Give me a status. How are you feeling about this now, especially if you were kind of wary before the notes? Okay, because we've got a lot more examples to do here. We've got a lot more going on. Kind of better, a little. Okay, it just takes practice. Okay, let's try some more of these, y'all. Let's look at this next one.